Hello guys, we are gonna continue this pre-security, you know. Let's go with cloud fundamentals. Wait a sec. Uh, let's go, guys. Mm, I forgot to bring my stand. Let's forget it for today. We'll start with tomorrow. Let's try it. Uh, Wait a sec. Let's go. Cloud computing fundamentals. Let's start introduction. Imagine you have a fantastic idea for an app that helps students practice cybersecurity and you host it on your own computer in your country. But what can you do when users from other part of the world try to access it and experience lag? What if many students connect at the same time or your computer is turned off? These limits make it hard for the app to grow. That's when cloud computing comes to play and solves this problem. The cloud is built on top of technology you already learned, like virtualization and containers. These enable running many applications efficiently on shared infrastructure and quickly creating or changing environments when needed. In this room, we will explore the basics of cloud computing and how this impacts the way modern applications are built, developed, and used every day. Learning objective. What is cloud computing? Service model of cloud. LAS, PaaS, SaaS. Cloud types. Private, public, hybrid. Benefits of cloud computing. How big companies are using the cloud. Virtualization room. We did this for. Let's go. Cloud computing is a perfect solution for the challenges in the application you have designed, such as moving your file from a single laptop to online storage that you can access anywhere instead of running your app on a one computer in one country. The cloud lets you use computing resource over the internet. This makes your application easier to access, more reliable and ready to grow as more students start using it. How server evolved to cloud. Before we start diving into cloud details, it's helpful to understand that the cloud computing did not appear suddenly. It is the result of many years of changes in how servers were used and managed. At each step, business looked for ways to reduce costs, use resources more efficiently, and make their application easier to run and scale. The timeline below shows this evolution from physical server to the cloud we use today. Evolution of cloud. Physical server era 1960s to early 20s. Physical server in a company building, one server is equal to one job, expensive, slow, scale. Virtualization 1999206. Multiple virtual servers on one machine, better hardware utilization, faster provision. Automation and remote management 203 2206. Server managed over the internet. Early automation infrastructure become faster and flexible. Cloud computing, AWS launch 206. Rent virtual computers and storage on a demand, no hardware ownership, elastic scaling in minutes. AWS Azure Cloud, Google Cloud, containers focus on app, not servers, global scale platforms, modern cloud era, 2012 to today. Cloud benefits and characteristics. After seeing how applications evolved from physical server to the cloud, it becoming clear why cloud computing is widely used today. The cloud was designed to address common problems including limited capacity, high cost, and slow growth. The following benefits and characteristics explain how cloud computing makes application easier to run, scale, and manage. Scalability easily scale up or down as your applications need change. On-demand self-service create or remove servers and storages instantly without waiting for hardware. Pay only for what you use. You are charged based on the usage, not upfront cost. Security cloud provides protect the infrastructure with the strong security measures. High availability. High availability. Application keep running even if part of the system fails. Global access. Your application can be accessed by users anywhere in the world. In simple terms, the cloud enables IT resources to be flexible, cost effective, and easier to manage. Types of cloud. The flexibility provided by cloud computing allows application to be run in different ways depending on your needs and levels of control. Because of this, cloud providers offer multiple models for developing and using application, each suited to different scenarios. Let's start with the development types. You can choose for a cloud environment, public cloud, used by startups, websites, and global apps because it is affordable, easy to scale, and require no infrastructure management. Public cloud services are preferable for nearly every use case. Private cloud used by bank, healthcare, and government organization because it offers greater control, customization, and compliance for sensitive data. Hybrid cloud used by companies like e-commerce platforms that need to keep sensitive data private while still scaling publicly during high demand. Just like there are different ways to deploy a cloud environment, there are also different ways to use cloud service. Depending on your experience and needs, you can choose the level of responsibility that fits your application. Let's look at the main cloud service models. Infrastructure as a service infrastructure as a service LAS. You rent basic computing resources such as a virtual servers, storage, and networking. You are responsible for managing the operating system and your application, while the provider manages the physical hardware. That is SaaS. Platform as a service PaaS. The cloud provider manages the infrastructure and the operating system. You focus on building, developing, and running your application without worrying about the server. That is PaaS. Software as a service SaaS. You use a complete application over the internet. The provider manages everything and you access the software through a browser or an app, for example, Gmail or Zoom. Think of cloud service models like a different ways of renting a place to live. LAS versus PaaS versus SaaS. Renting an apartment analogy. Renting an empty apartment. You choose the furniture, install appliance, and handle maintenance inside the house. PaaS renting a semi-furnished apartment. The basics are already set up. You can move in and focus on living, not on installing all the infrastructure. Such staying in the hotel, everything is ready to use, cleaning, maintenance, and service are handled for you. Wow, it was very good example. Major cloud vendors. There are several cloud vendors offering a variety of service, but Amazon Web Service AWS is the industry leader with the most extensive offering and global search. Other well-known cloud providers include Microsoft Azure, a strong computer competitor, especially in enterprise and hybrid cloud environment. Google Cloud Platform (GCP), known for powerful data analytics, AI, and machine learning tools. Alibaba Cloud, a major player in Asia offering competitive cloud service globally. IBM Cloud focuses on hybrid cloud and AI-driven solution for business. Oracle Cloud focuses on enterprises applications and databases. Each of these vendors offers a range of service, but AWS remains the most popular due to its vast infrastructure and support for business of all sizes. How companies are using the cloud? Netflix runs its entire platform on AWS so it can scale globally, stay online during peak demand, and stream content reliably to millions of users at once. Spotify uses the cloud to handle millions of songs and users, scaling quickly when new music or features are released. Instagram relies on a cloud to store massive amount of photos and videos and deliver them fast to users around the world. Online stores use the cloud to handle traffic spikes during the Black Friday without buying apartment permanent infrastructure. These companies use the cloud because it lets them scale easily, reduce cost, stay reliable, and focus on improving their products instead of managing hardware. Next, you will apply these same ideas by developing your cybersecurity training app in a simulated cloud environment. What is the characteristics of cloud environment that enables you to handle an unexpected increase in the access of your application? Characteristics of cloud environment that enable you to handle an unexpected increase in access of your application. Uh, what could that be? Dear cloud benefits and characteristics. What was the question? Character cloud environment that enables you to handle unexpected increase in the access. Uh, Scalability. It is this one, all right. Paste. Is that correct? Yes. What is the most common type of cloud development used? Common type of cloud development used. Uh, Here it is development. It must be cloud, right? Public. Maybe because it's a public, so most of the companies run this, I guess. Or not, maybe public, private, I don't know. Yes, it is public cloud. Suppose you want to deploy an application to the internet, focusing only on the application development and leaving the infrastructure to other. What type of cloud service is this? That is, where is that? It is PaaS. Is that correct? Yes, it is correct. Let's go. Deploying a cloud instance. Oh. So far, you have learned what cloud computing is and why companies use it. And now it's time to use those ideas in action by developing a cloud environment to launch your cyber security app training. In this exercise, you will use a cloud interface similar to AWS platform. The goal is to not memorize button, but to understand how cloud resources are easily created and managed in real world scenario. Open a cloud console site by clicking view site. Let's go. Hmm. Uh, Basic cloud terminology. To complete this exercise, you only need to understand few basics. A few basic concept of AWS, E2C, EC2, EC2, Virtual Computer Server. EC2 presents a virtual computer in the cloud. Just like a real computer, it has a CPU and memory and can run application. Whenever you add an EC2 instance, you are adding a computer to your environment. Instance type, for example, T233M5. Instance type describe describe how powerful the virtual computer is. Some have more CPU and RAM and are therefore more expensive. You choose the instance type based on your needs, knowing that the biggest instance is equal to more power plus higher cost. Minor instance is equal to less power plus minus lower cost. Developing your environment. You will create three virtual computers EC2 instance to host your cybersecurity training application. This aligns with the infrastructure as a service LAS model you previously learned. As a cybersecurity practice often require full access to the operating system. This allows you to install tools, configure system, and safely simulate attacks and defense just like in real world environment. Picking a region. First you need to choose a region where your resources will live. You can do it in the top right of your screen. Uh, I only know this. What is Virginia, Oregon, Ireland, Sao Paulo. Alright, we will choose that. As a region represents a geographical location, for example, Europe or North America. Creating virtual machine. Now go to create virtual machine. Where is that? Uh, oh, here, create virtual machine. Uh, Go to create virtual machine. Block on the right side of the page to create a virtual machine. Let's do it. Uh, Application interface. Interface. Uh, it is correct, right? Running create VM. Do we need to start it? Now let's create two testing computers for the user to practice their cybersecurity skills. Since these are the test machine, let's use the more powerful instance type M5 large. I need to create this. All right, one is done. Now what the hell is that? Machine one. All right. Uh, M5. All right. It is running. Create. Now there is another one. It is study machine 2, right? Study machine 2, same biggest money and create. After creating the two new machine, your instance block should look like this. Let's see. Yes, it is looking like that. Billing analysis. Let's analyze how much credit is costing our environment by navigating to billing section at the bottom of the page. There you can check how much each type of instance is costing you as well as the total. No, there is, here it is. It is around 170 bucks. Currently, you are still developing your application, so users have not yet accessed your platform. We can optimize cost by stopping the two study machines and reviewing the new cost of your environment. Go to instance block, go to instance block, uh, and click stop button for the both machine 1 and 2. All right, stop. It is stopped. Go to billing section and you should see that the cost has reduced. Yet now these two are they are not paying the money, only these three. All right. This exercise is a clear example of how easily you can manage your cost in the cloud environment. Answer the following question to conclude your learning about the cloud. What is the total cost of credits of the entire environment if study 1 and study 2 are stopped? That is 30. As you can see it is here. How many credits does a M5 EC2 instance cost per month? That is 70 credits. What is the total cost of credits if only the new instance we created are running? Let's see. This is theirs. Let's see. That is 150. 150 credits. What would be the total running cost of the entire environment you created if you add a third study machine? Uh, there is not a machine. Let's create one. They want a study machine. It will be 3 and it is small. Create VM and we need to stop. That is stopped. Let's see. That is 168. 168. See why it is wrong. What would be the total running cost of the entire environment you created if you add a third study machine? Are they asking about the total? Let's see. That is 188. Is that the right answer? Yes, that is. I thought you can see you created, right? I created only this much. This one already existed, so whatever. Conclusion. In this room, you explore the core ideas behind cloud computing and how it enables flexible, scalable, and cost effective access to computing resources. Key terminology. Sec, I will read it later. Key terminology. Let's quickly review some concept we learned in this room. Public cloud. Cloud service you access over the internet that may that many people and the companies share. Cloud Cloud service you access over the internet that many people and companies share. Private cloud. The cloud built just for your one company so they have more control and security. Hybrid cloud, a mix of public and private cloud that can work together and share data. LAS, a service where you rent a basic computer parts like server storage from the cloud. PaaS, a service that gives you a ready-to-use environment to build and run apps without managing servers. SaaS, software you use online without installing anything like Gmail or Zoom. EC2, Amazon Cloud Computer that you can quickly create, use, and resize whenever you need them. We also concluded that the key benefits of the cloud computing are scalability, on demand self service, pay online for what you use, security, high availability, global access. Further learning, you are now ready to explore the next key area, operating system in the operating system introduction room. You will learn how OS components manage hardware, processors, memories, and the security. This knowledge is essential for understanding how cloud system run application behind the scenes. That's it for today, guys. Not today. That's it for this video. Let's go. Wait a sec. There will be a rewind, right? Let's see. Hey, give me the reminder. Remind. A sec. I can just go back, right? Learn. Security. That is not available. Should be popping up somewhere around here. It's not popping up. Don't know, man. What is happening? Should I go like that? There is no coming of that. Let's see. Auto obvious of the recording. Start recording. I will be back in a minute, guys. Wait a sec. I am back. After drinking some water. Sooner I let's go with this professor today. Person. Commerce. Operating system production was basic for today. We will continue others sometime. Let's go. Base security, new operating system basics, operating system introduction. Let's go with this room. Why there is attack box? Do we need an attack box? Let's see. Do we need an attack box? Yes, we need this. Oh, we will use the attack box this time. For a while, I will use the attack box. Let's see. Start. Oh, I am starting the Kali. And attack box, we will use it for the time being. Uh, Introduction. You turn on your phone or laptop every day and everything just works. App launches, file opens, music plays, and the whole system feels seamless. But what actually makes all this possible? In the computer fundamental module coming soon, you explore the physical components of the computer and the different types of computing device. Now it's time to uncover the invisible layer that ties it all together, the operating system or OS. Scenario: your friend just upgraded their primary computer and knowing you are getting into tech has generously gifted you their old machine. It's been sitting untouched for a while and you can't remember much about it. Only that is only that it used to run well. Before you can decide whether to upgrade it, wipe it, sell it, or turn it into your next project, you need to figure out precisely what you are dealing with. Learning objective: understand what an operating system is and the role it plays. Explain the core duties of operating system. Identify common OS type and their typical use cases. Practice interacting with an OS to gather system information. Prerequisite is: before you begin this room, it is recommended that you complete the Computer Fundamentals module of the pre-security room. This room builds on core ideas introduced earlier, especially your understanding of computer hardware, devices types, how modern the system boots and operates. We did all that. Let's go. I understand the learning objective and ready to learn about the operating system OS. Invisible Manager. An operating system OS is the core software that coordinates everything happening on the computer. It sits between the user application and the system physical hardware, acting as an invisible manager that keeps the entire machine running as one unified system. User application, operating system, and hardware. It goes like opposite: hardware, operating system, application, user. A helpful analogy is to think of your computer as a busy airport with all the components functioning together. Your hardware, CPU, RAM, storage, connected devices, the runways, airplanes, fuel system, radar, and the other physical infrastructure. Your application, web browser, game launcher, the various airlines and their passengers all trying to take off, land, and request service. And your operating system, Windows, Linux, Mac OS, the entire air traffic control system, directing all of this activity. It schedules resources, manage traffic, resolves conflict, and ensures safety. We need an operating system because it provides this all important job of coordination and structuring that make the modern computing possible. Without an OS, each application would need direct control over the CPU, memory, files, devices, and security. This would likely cause conflict. The OS handles this by acting as a central organizer. In the computer fundamentals room, you learned about the various computer components and their duties. Now we will see how the operating system manages and allocates these resources when you use your PC. System privilege layers. Inside a modern computer, different parts of the system operates at various permission levels. Some components can communicate directly with the hardware while the regular application run in a safer restricted environment. This separation is intentional and helps prevent conflicts and security issues. Kernel space. The privilege locked down core of the OS. This is where the kernel, the part of the operating system that directly manages hardware and the system resources, runs. It has unrestricted access to the CPU, memory storage, and all the hardware components. Kernel space, user space, where all the standard application run. Application in the user space are deliberately prevented from accessing hardware directly. Whenever they need to open or save file, play a sound or connect to Wi-Fi, they must make a system call and request that the kernel act on their behalf. System privilege layers, kernel space and user space. Building on our airport analogy, let's zoom in on the concept of privilege separation. Kernel space is a control tower, a strictly secured area where only trusted air traffic controllers the kernel work. They alone can directly control the runways, radars, and other hardware. Applications in the user space are like airlines and passengers on the ground. They can't enter the tower or touch the equipment. Instead, they radio request system calls to the tower, which handles them safely. This separation keeps the OS reliable. 140 app can't crash the whole system, just as no airline can operate safely without the tower's control. Operating system duties. Now that you know that what an operating system is and how system privilege is separated, let's look at what is actually does behind the scene. Every OS is responsible for a few core duties that allow your computer to run safely, efficiently and predictably. OS responsibility and what OS does. e- Examples. Let's see. Process management. Create schedules, prioritize, and terminates running programs. The OS decides how much CPU time each processors get, making multitasking feel seamless. Example, opening a multiple app like your browser, music player, and the social media without your computer freezing. Memory management allocates RAM to the processors, protect the app memory from the other processors, and reclaim memory when apps are closed. When RAM runs low, the OS uses virtual memory to keep your system stable. Opening the multiple apps at once, the OS allocates RAM to each one and keep them isolated so they don't interfere or crush each other. Operating system responsibility. File system management organizes file into directories, handles naming, path, permission, metadata, name, size, type, timestamps, creating a new flavor folder, saving a photo, or setting a file to ready only. User management handles multiple user account authentication and permission to determine who can access what. Logging in with your password and keeping your files inaccessible to other user account. Device management loads driver and provides a universal interface hardware abstraction layer so apps can say print this or play this sound. plugging in a new mouse, printer, or an external hard device and having it work immediately. Operating system security. It is important to understand that the OS also act as a security foundation. Before any antivirus, firewall, or a security tool is introduced, the OS is already enforcing the protection in the background, some of which we covered above. At the basic level, your operating system handles authentication, verifies who you are through the login password and biometrics permission, control exactly what each user and app is allowed to read, write, or execute. Isolation keep the every process in its protected box. Kernel/user space separation. System protection safeguard critical system files and setting for unauthorized changes. Getting on and so now that you have a solid understanding of what operating system is and its main duties. Uh, uh, remember your friend, he doesn't know how much PC he gave you. So let's dive in and try to gain some initial information about what you are working with. On the desktop of the machine, there is a shortcut named about this computer. This opens your computer system monitor. Go ahead and open it now and you will need it for some question in the task. Answer the question below. Which OS gives unrestricted access to your computer's hardware? Uh, so I need to go to this. Let's. I can't make it bigger. All right. Uh, which OS has a unrestricted access to your computer's hardware? Available here. System status. Uh, System. What the hell? Is that the wrong answer? What might that be? Which OS space has unrestricted access to your computer's hardware? What the hell might be the answer? There is nothing I can see. This might be the answer. Let's try it. No. Let's see. I need to answer from above, not from this. Which OS responsibility manages user accounts and authentication and the permission? That is, uh, user management. Maybe wrong, I don't know. Let's say it. It is correct. After opening the about this computer shortcut, you are greeted with an overview of the system specification. What version of Ubuntu Mate is your computer running? Uh, 126, 126. Check out the hardware section of the system tab. How much memory is allotted to your machine? That is 9. Check out the hardware section of the system tab. Oh, oh, oh. I am always wrong, guys. Sorry about that. I can be wrong. Voice interaction and landscape. We needed that, man. I don't know, man. I don't know. Let's start with that. OS interface. Now that you have some solid understanding of the operating system and its various responsibility, let's look at how we interact with the OS. Interaction with the OS can be divided into two main parts. The GUI graphical user interface and the command line interface CLI. Graphical user interface GUI is what you are most likely used to interacting with. It provides a graphical representation of all the information you want to access on your computer. Think of a folder icons, windows for your application, and menu for setting. We can imagine the analogy of using a navigation application. You tap an icon or place you want to visit. The app generates the direction for you, eliminating the needs for typing. Command line interface. Command line is where you enter specific text-based command to retrieve or manipulate information. Instead of clicking on icon, you tell the computer exactly what you want using words and syntax that the system understands. This gives you far more precision and control and speed, especially for advanced tasks, but it requires familiarity with the commands. Back to the map analogy, using CLI is like entering the exact GPS coordination of your destination. It's direct and extremely accurate, but only if you know the correct information to type. Later in this model, we will explore CLI on both Linux and Windows to learn how to navigate files, inspect file system, and interact with your OS beyond GUI. In the screenshot below, you can see that the GUI and the CLI are both used to retrieve the same information. In this case, to display the contents of Ubuntu user home directory. The GUI requires a flick for the folder navigation, whereas CLI requires a command to list the directory contents. Oper- Operating system landscape. Nice. We are gaining a much clearer picture of OS, its responsibility, and how we can interact with it to manage our computer. Now it's time to look at the bigger picture. Not all the operating systems are the same. Different devices or jobs demand different designs, ranging from your phone to web server in the data center. Below are the five major categories you will run into in the real world. Operating system type, primary use case, key characteristics. Desktop, operating system type, desktop. Personal computer, daily work, gaming, content creation. Key characteristic, rich graphic interface, run many apps at once, user focused. Server, web hosting, database, cloud service, backend. Headless, no give you maximum uptime, multi-user, remote access. Mobile, smartphone and tablets. Touch-based UI, power efficient, always connected, app sandboxing. Embedded, appliance, cars, IoT device, smart TVs, router. Tiny footprints run on a limited hardware. Virtual cloud, virtual machine, container, cloud, cloud instance, sorry. Lightweight, scalable, rapid development. Real world operating system. Now that you have seen the different types of operating system and what they designed for, let's look at the major families of operating system you will encounter in the real world. Each family fills one or more of the OS type we just explored. To keep things organized, we will highlight the common version of the distributions you will see in each and follow the same categories as above. Desktop, server, mobile, embedded, and virtual cloud. Desktop. Windows, the most widely used operating system on the personal computer. Windows 10, end of life, Windows 11. Mac OS. Apple's desktop OS, known for its foolish GUI and integration with other Apple devices. Sonoma 14 and Sequoia 15, Sequoia 26. What the hell is that? Linux, not a single OS, but a family of open source operating system called a distribution Ubuntu, Debian, Fedora. Server, Windows, used in the large network data centers and corporate environments. Linux, sorry, the vast majority of web server trusted for its reliability and open source nature. Ubuntu Server, Debian, and CentOS, Red Hat. Unix, large enterprise, finance, telecom, government, IBM X, Oracles. Mobile, Android, iOS, the most widely used mobile OS which runs on phones, tablets, and smart devices. Android 15, 6. Apple's mobile OS is running on iOS, iPads, and other devices. OS 17, 18, 26. Embedded and IoT devices. Embedded Linux. Specialized OS built into a device with a dedicated function. OpenWrt, Ubuntu Core, Yocto project. Real-time OS designed for app where tasks need guaranteed response time. Aircraft control, CRTOs. virtual and cloud and VM. A massive data center that hosts the website, apps, and streaming services. Ubuntu, LTS, Amazon Linux, Ricky Linux. Container optimized. Lightweight alternative to VMs that package just the app and its dependencies. Alpine Linux, Bottle Rocket AWS, Flatcar Linux. Why so many operating systems? Different devices and the environment require different capability from the OS. A laptop must be user friendly and support multitasking. Server requires stability. Stability must be able to run continuously without interrupting. Mobile devices need power efficiency and hardware integration to extend battery life. Embedded systems use lightweight operating system designed for specialized purpose. The companies and communities that develop this operating system also have their own goals. Some focus on ease of use, performance, security, and openness or customization because each environment values different capability. No single OS is the perfect fit for every situation. Instead, an ecosystem of operating system has evolved. Continuing a reverse investigation, from the previous talk, you learned that your new computer is running the Ubuntu distribution of the Linux. Were you able to determine the version and the release? That's, that's the directory which can be found on your computer's desktop. Open the file system tab in the system monitor. What type of what type is listed for dev root device? Let's see. About this. ये ओपन क्यों नहीं हो रहा है फाइल सिस्टम uh, what type that is X4, what is that meaning? I don't know. EXT4. After opening the home directory on the desktop, how many user directories exist? Let's see. Uh, there are three. Navigate to Alex home directory and explore the document folder. What is the flag value contained in the node.txt? Let's see. cd alex ls documents cd documents ls there should be a node.txt get node.txt. Let's see, there is a flag. Hope you enjoy the new computer Alex and this flag. THM new PC for free. Very easy. And there goes our termination. And it is also should be terminated. Let's see. Well done, you have reached the end of operating system introduction. In this room, you learned what an operating system really does behind the scene and explored a key concept, including privileges, user management, memory handling, and the processes. In the practical exercise, you investigated a mystery computer gifted to you by a friend who used the operating system to take a peek into the hardware and the file system it helps manage. Key terminology. Let's recap the core term you learned. These definitions will help solidify your understanding before moving on to further learning. OS, the core software that manages the hardware application and all the system resources. Kernel space. OS highly privileged area with a direct hardware access and the home to the kernel, which directly manages the hardware and the system resources. User space, the area where the regular application run with the limited permission for safety and the system stability. GUI, graphical user interface, a visual part of the OS, Windows icons and menu, that lets you interact through clicking or tapping. Command line interface, a text-based interface where you type commands to control the system with the precision and speed. Further learning, in the following room of the operating system module, you will dive deeper into Windows and Linux operating systems, learning how to navigate each system using both the GUI and the CLI. You will gain further hands-on experience performing real tasks, gathering system information, and interacting with the OS. Complete the room. Windows Basics. I think there is lots to read, man. Why it is so damn readable? Uh, uh, Wait a sec. I need to stop this. Again, start it. Hello, guys. We are doing again. Free security new operating system basics, Windows basics. Let's go with. Let's go learn how to navigate Windows, manage files, and use essentials. Every operating system has its own personality, and if you have used a computer at school, work, or at home, there is a good chance you already met the most familiar one, Microsoft Windows. In the previous room, you explored what an operating system is, the behind the scene manager that keeps your device running smoothly. Now it's time to step into a real example and see if previously learned the concept takes shape on a system you may already organize. In this room, you will get hand-on experience with the Windows interface and begin building a practical skills that will lay the foundation for the sub- subsequent rooms of the models. Scenario: in this room, you will take on the role of a new employee starting your first day at TryHackMe. Once you log in to your workstation, you will get to know the Windows desktop, learn how the interface works, open tools from the start menu, and find your way through company folders. Your supervisor will guide you in creating and organizing files, changing system settings, checking the task manager, and reviewing basic security settings. By the end of this onboarding task, you should feel comfortable using Windows and handling the daily tasks you will be expected to handle. Learning objective: navigate the Windows graphical interface, including the desktop. taskbar and the start menu. Use the file explorer to browse folders, understand the file path, and organize the file effectively. Check system settings and personalize the Windows environment using the system app, setting app. Use the basic system tools like Task Manager and the Windows Security to monitor performance and verify system protection. Prerequisite is work through inside a computer, computer types, operating system. I have gone through all this. You need to start this. Let's go. I understand the learning objective and I am ready to learn about Windows. Oh, we can write. No answer needed, all right. Uh, can I read it from here or you? Let's see if you can read it or not. I think you can read it, right? Yes, you can read it. Let's go. Before Windows had its current polished look, Microsoft operating system were much simpler. Early computer run MS-DOS, which showed a black screen where you had to type commands instead of clicking icons. In the 1985, Microsoft released a Windows, a basic graphical user interface built on top of DOS, introducing Windows menu and the mouse controls to personal computer over time. Windows has added the more features which turn the origin shell into complete operating system today. The modern Windows OS is the result of those changes. Let's dive into Windows and see how the operating system concept you learned about in the previous room present themselves in the world's most widely used desktop operating system. Windows 1. Wow. Windows ME 2000. Windows 11. What a changes. This very different. Logging in and authentication. Before gaining access to the Windows desktop, you must authenticate to your identity to the system. The authentication process verifies your identity and determines the actions you are allowed to take once logged in. When the Windows system starts, it displays a login screen where a user account must be selected and authenticated with a password pin or another verification method. Each user is assigned a set of permission levels that determine their access to file settings and the system functionality. Windows commonly uses the account types below. Guest, a restricted account intended for temporary access with a minimal permission and no ability to change system settings. Standard, a user account for everyday tasks such as running application and changing personal settings without access to system-wide changes. Administrator, a privileged account with a full control over the system including software installation, configuration changes and user management. Upon starting the machine in the previous task, you are automatically logged in using an administrator account. This will allow you to explore system settings, install program, and the perform administrative action without being restricted by the permission limitation. Windows Desktop. In the last room in this module, we explore the comparison of an OS to an airport. Let's continue with this analogy. If you the user are passenger and the login screen represents the airport security checkpoint, you can consider the desktop to be airport terminal. After entering it is a final area you gain access to and all others Subsequent areas branch out from this point. Let's have a look at a Windows desktop and cover some of its core features together. When you first log in, you are presented with two main areas. Desktop, the main workspace where the file, folders, and the shortcut lives. Taskbar, a control strip that provide access to application system, tools, settings, and notification. Let's break this down further to get a better picture. Please note that the instant used in this room and the screenshot below are using using Windows Server 2019, while newer Windows version may differ slightly. These core components are concept remain and consistent. Desktop icons shortcut to the items like recycle bin, folders, and frequently used application is truly customizable. Start menu, a primary way to access application settings and power option. From here. You can log out, restart, and power off quickly. Search, quickly find application files folder and the system setting by using keywords. For task queue, allow you to see all the current open windows and quickly switch between them. Pinned application and the folders, your most used application and folder can be pinned here. My eye is paining so bad, dude. Network and audio setting. This section can be customized to suit your needs. Date and time opens up to full calendar. Date and time setting can be accessed here. Notification display, computer and application notification network, and the other setting can also accessed. Start menu. When using Windows, the Start menu can be accessed by clicking the Windows icon located at the bottom left of the taskbar. If we consider the Windows desktop to be the part terminal, the menu is the Department Board of Information desk. It is the area where you see what is available, apps, file, folder, settings, and power options you can think of as quickly as possible. Built-in tools and apps. I am getting very sleepy. Well, guys, I am gonna sleep. I am having very hard time. No, no, man. I need to complete this today. Let's go. Ah, where it is? We missed it somewhere. Yes. Oh, you know what is start menu, right? This is the start menu. You will see all these quick accessible apps and setting folders, user built-in tools and apps. Windows ships with the many useful built-in tools and applications that you will use daily. Beyond the wide range of settings available to manage your system, Windows also includes simple but powerful tools such as Notepad for editing text files and File Explorer for navigating and managing files. These tools are available immediately and form the foundation of everyday Windows usage. All of them can be accessed via Start menu and search bar. The built-in tool on Windows are like airport services already available in the terminal to help you get the task. Calculator, Notepad, File Explorer, Paint. Getting system information. Windows includes a built-in settings application that allows you to configure and view information about your system to get to know your new work PC better. New work PC better. You will start by investigating the machine. We are working with the machine. the setting app. There is a helpful section called About Your PC that provides key details about the system. A shortcut about your PC has been created on the desktop. Open it now. Alternately, you can practice using Smart Menu or search features to locate it. And the About Your PC page provides an overview of security device and the operating system information. We will use this information to become familiar with our environment and begin answering the first question in this task. Oh, we will need to go to about PC. All right. File file exploration and management. Great. Now we have an understanding of the system we are working with. Let's take a look at how Windows handles file exploration and management as we can access some of the onboarding documents for your new position before we dive into using new File Explorer. Let's quickly cover how Windows organizes files and directories. Windows uses a hierarchical folder structure, meaning folders can contain other folders and files inside them. This structure helps keep data organized and make it easier to locate information such as system grow larger, command location such as the desktop, documents and downloads serve as a primary directory for storing files within this location. Subfolders are used to group related files together. Understanding this layout will make navigating the system and the managing file much easier. We will continue the airport analogy. File Explorer act as the directory and floor map of the terminal, helping you navigate between different areas and locate what you want. You can now open TryHackMe onboarding folder on the desktop. Alternately, you can open the File Explorer application, which is pinned to the taskbar, to use the Open TryHackMe onboarding folder on your desktop. This open the folder in the Windows File Explorer. Options for viewing and sharing and editing the folder files. Click the folder name will show us the full path of the chosen. I do not see it here. As you can see, I need to go like this. Oh, I need to go like that. Sorry about that. The display contains our chosen folders. We can use the File Explorer to build a search function to search for uh, 1, 2, 3, 4, 5, 6. Let's see. Please ensure the virtual machine is open in split screen. Then take a look at the computer's desktop. After opening about your PC, navigate the device specification section. What is the device name specified? Let's see what is the device name. About your PC. Uh, your PC is monitor and PC name. TryHackMe. TryHackMe. Continue looking through the device specification. How much RAM is installed on your new work PC? There is 4 gig RAM. Scroll down to the Windows specification section. Which version of the Windows Server 2019 data center is installed? That is 1809. Explore the TryAdme onboarding folder located on your computer's desktop. What is the flag value found within the welcome.txt? Uh, let's see. Copy. What is the welcome TryHackMe. Within this folder, you will find everything you need to start with your. That is load of crap. Oh my god, how much reading it is. Let's go. Applications are the programs. Let's see. Let's. Applications are programs and the tools you use to perform tasks on your computer, from browsing the web and editing photos to managing. Yes, that is very fast. Let's see. Let's see. Let's keep it from here. Sitting on your PC. We already discussed a few of the built-in application Windows provides, but knowing how to install, update, and remove the application is a core skill for everyday window use. Let's briefly visit the airport analogy to gain better understanding of this concept. Updating your OS and app is like changing flight or reserving a seat. Installing a new app is comparable to scheduling a new flight, and removing app is like a canceling a booking you no longer need. These three processes enable you to make necessary changes to your operating system, ensuring you have exactly what you need and your system remains secure. Updating your application. Keep your operating system and the applications up to date is an important part of maintaining a source and stable system. Update will often include security patches, performance updates, and bug fixes. Windows Update. Windows includes a built-in update tool called Windows Update, which keeps the OS and some native application and the security features up to date. Windows Update can be accessed through the setting app and may install updates automatically depending on your configuration. Sorry, what is this file? Let's see. Ah, updating application. Application updates work differently depending on how the software is installed. Built-in application may update automatically in the background. Third-party applications often include their own update mechanism. Some applications will prompt you to update upon launch. Some require you to check for updates or download a new installer manually. Installing application. Now that you have seen how updates work within the Windows OS or OS, let's take a look at installing new ones. Microsoft Store provides a curated soft space option for installing apps to Windows, although it's not available by default on Windows Server. From the internet, it may environment. In many environments, apps are installed by downloading an installer directly from the trusted vendor's website. They usually exist in a exe or MSI file and guide the user through the installation process. As all installation. Great. Now you have a solid understanding of updating and installing a new application within the Windows environment. Let's get add-on and install an app. Within TryHackMe onboarding folder on your desktop, you will find an installer named TryHackMe Welcome. Proceed the double click and install and start the Feel free to click through the installation option. Remember that this was violation safe and testing. Let's see. Install finish. Yes, we installed it. THM your first day. Set a flag. Was around here, right? Uninstalling the application. In the Windows environment, there are multiple ways to uninstall the program using the Microsoft Store for uninstalled installed app, add or remove programs features in the system setting, uninstall program section of the control panel using the application built in. Alright, dive into setting. In the previous task, you explored about your PC section of Windows setting. Now we will take a closer look at the abundance of configuration available to us. There are two primary ways in which a Windows user's car modifies environment. There are existing shortcuts for each of the tools below. Place Windows setting, a modern centralized location for configuring system, device and personalization and security setting in the Windows. Control panel, a legacy management interface that provides access to older system configuration tools, skills required to specific administration tasks. Windows setting. Windows setting and the control panel enable you to view and modify how your Windows system operates. From these two applications, you can manage system preference, including display and audio setting, user accounts, app, network options, accessibility features, and security configurations. Task Manager. Task Manager is a built-in Windows tool that allows you to monitor what is happening on your system in real time. It allows you to view running application and the background process as well as check system performance including CPU and the memory usage. A shortcut to Task Manager has been placed on your workstation desktop. Go ahead and open it now to view your currently running application to check on your system's performance. Task Manager has 5 tabs to help you keep track of your situation, system, process, currently running apps, and the background process and their resource usage. Performance, graph, and static for system resource for such as CPU, memory, and network. User, currently logged in user and user resources. Details, a more technical view of running progresses including a process ID, PIDs, service, Windows service, and the current state stop. Native Windows security. Windows offers built-in security tools designed to help protect your system from threats such as malware, insecure application, and unauthorized network access. These are enabled by default and allow the monitoring and the control of your system security. Windows security. Windows security application is your central dashboard for managing Windows. Built-in protection measure. It is provided Our four main scenario each focusing on different area of system security. Virus and threat protection help detect and remove the malicious software using real-time protection and the customizer scan. Firewall and network protection controls incoming and outgoing network traffic to help prevent unauthorized access. App and browser controls perfect user from potentially unsafe app files and websites. Device security provides a hardware-based protection that help secure the system. Let's take a closer look at the furnace and the threat protection section. Windows security on your workstation. Go ahead and open it. Where it is? Let's take a virus and threat protection section of your Windows security on your workstation. Go ahead and open it. If you're using the desktop shortcut or a start menu, virus and threat management. It is in the virus and threat management. No, that is not in there. Uh, where is that? Yes. Open Windows Security using the shortcut on your desktop and select Virus Threat Protection section. Choose Scan option. Uh, select TryHackMe ongoing. Your custom scan will have found a completely safe test file, and this process shows how Windows is capable of scanning and measure Windows as the place to help you secure your system. Go ahead and click see detail to investigate. Windows Defender Firewall. Windows Defender Firewall is a built-in firewall designed to help protect your computer from unauthorized computer traffic, network traffic. It monitors network connection and applies rules that determine whether the connection are allowed or denied. The firewall operates on different network profiles, allowing you to create a custom rules or specify applications that are permitted. Domain used when the system is connected to organization's domain network. Private intended for trusting networks such as home or lab environment. Public may I use be used for checking out the advanced setting of the Windows Defender firewall. You can view an overview of firewall inbound, outbound, and the connection rules. A detailed view of new each rule, including name and the status and the action. Create a new rule for filter. The TryHackMe welcome installer located within the TryHackMe onboarding folder. What is the flag you receive when after installing? Investigate the time language section from the Windows setting app. Which country or region your computer is currently at? Uh, which country I am at? I guess I need to go to this. Sunday, yeah, this region, United States. Very easy. States. United. Open the task manager on your computer workstation. Uh, and navigate to users tab. Which account is currently logged in? Uh, which account is current administrator? Baba. After performing your custom scan, click virus file and select C details. What is the file name shown in the after matched item section? Uh, 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 click scan. Click scan. What is the file name shown in the after performing custom client? Click. Uh, uh, what is the file name? What is this? After performing custom scan, Oh, okay. My God. Conclusion. Nicely done. You have reached the end of the Windows basics in this room. You explored the fundamentals of the Windows. I struggled there with I didn't know that how to that go to that section. Sorry about that. Windows Android, you completed the your first TryHackMe using the Windows Server 2029 2019 operating system to read files, install programs, and run security scans on your new workstation. These skills are foundation for both general system usage and the deeper technology understanding later on your learning and the professional journey. Key terminology. Let's recap the core terminology and the application you have learned about this room. These, deten- these definition will help solidify your understanding before moving on to further learning. Desktop, the main workspace where the files, folders, and the shortcut lives. Taskbar, a control strip that provides access to application tools, settings, and notifications. Start menu, the primary way to access the application settings and the power options signified by the Windows logo. Search, a quick access method for locating application settings and file by entering this search item. File Explorer, a built-in Windows tool to browse, manage, and organize the file and folders. Windows Update, a built-in update tool that helps keep your OS native apps and security features up to date. Microsoft, a native Windows application for installing trusted application. Windows Setting, a centralized location for configuring system devices, position, and security setting. Control panel, a legacy management interface that provides access to system configuration options. Task Manager, a manager tool of monitoring what is happening on your system is real time. What Defender Firewall is the firewall designed for the learning. Hello guys, that's it for today. Hope you liked the video. Subscribe. Thank you for watching. Oh my god, I'm very sleepy. That's around 1 point. I streamed quite a lot.